In this video, we'll learn to order, add, subtract, and compare amounts or quantities using proper and improper fractions and mixed numbers. So all this means that we're gonna order and compare fractions and mixed numbers first, and then we'll add and subtract. But what are proper fractions? Proper fractions are the ones like this, where the top number is smaller than the bottom number, suggesting that this is less than a whole. The same thing over here. The top number 5 is smaller than 6, so that suggests that this is less than a whole. So this is called a proper fraction. And 5/4 though is an improper fraction because 5 is greater than the 4, suggesting that we're going to have more than a whole. And these two are called mixed numbers because they are a mixture of whole numbers and fractions. So 3.5, 1 and 4/5. So let's try and order them. So we're going to put them in order from the smallest to the biggest. Now, just by looking at the numbers, and as I explained beforehand, there were some that were smaller than a whole and some that were bigger than a whole. So I know for sure that these two will be here at the front. Which one will come first, I don't know yet. Then we'll have the other three numbers. But I'm thinking I could sort these out and place them here as well without doing any calculations yet. So we've got 3.5 and 1 and 4/5. So that immediately tells me that number in front, that whole number, tells me that this is bigger than this because it has 3 whole ones already, whereas this is less than 2. And looking at this one, this is more than a whole. So, but it's not anywhere near having 3 whole ones because then it would be 12/4 and 5 is not. 12 is much smaller than 12. So the biggest out of these would be 3.5. We agree with that. And there was this discussion between them too. Which one is the biggest so that we can put it here? If I try and represent 5/4, so that would be 4/4 here and another quarter. And if I try and represent this, so there is a whole, I'll do it out of 5 because this is what the fraction is telling me. So a whole, so 5/5 and 4/5. So if you try and compare this with that, as you can see, most of this is highlighted. So this is definitely bigger than this one. So we're safe to say that 1 and 4/5 is greater than 5/4. But again, 5/4 is actually bigger than those two because this is the only one that is greater than a whole. So I can place this as well here. Now it's a question of comparing these two. So 2/5 compared with 5/6. So I'm going to try and bring them to the same denominator because that means having the same number of slices and the same size of slices, so then they can be comparable. So 5 to bring to a number that can be divided by 6 and give whole numbers as well. So in other words, that's finding a common multiple. So multiples of 5 would be 5, 10, 15, 20, 25, and so on. And multiples of 6 would be 6, 12, 18, and so on. So the one that could be in common for both is 30, and I can easily do that by multiplying 5 by 6. So 5 lots of 6 or 6 lots of 5 give me 30. So I multiplied 5 by 6 to give me 30. So I need to do the same to this number at the top to keep the fraction the same. So 2 times 6 will give me 12. And in order to bring the 6 to 30, we multiply by 5. So we'll do the same to the top number. 5 times 5 is 25. Now it's very clear which one is the bigger one because they've got the same denominator. So this is 12 out of 30 and this is 25 out of 30. So 25 out of 30 is definitely bigger. So I'll place them in order here. So 12 out of 30, that was 2/5. And 25 out of 30, that was 5/6. So I've now placed them in order from the smallest to the largest. Now you're probably wondering if these improper fractions were not clearly the biggest ones, or if you had two mixed numbers that were very close to each other, how do we compare and order them? So that's what I'm going to show you now. So in order to bring the mixed numbers as close to a fraction, then we'd need to convert them to improper fractions, like these ones. So what I would do is convert these. So 3.5 means they have 3 lots of whole pizzas or whatever you're talking about. So I'll show this as, because it's halves, so I'll show this as 1, 2, 3, and I have there. So these are highlighted. So how many halves would I have in total? That would be 2, 4, 6, 7. 7 halves. And the shorter way to do it would be to look at how many parts there are in the whole, and that's 2, and multiplied by the number in front. So 3 times 2 is 6, and the 1 that we have already, so that is 7. So 7 halves. And trying to convert this other one as well, so we get 1 whole, so that is split into 5 equal parts, and 4/5. So that 5/5 already in there, because that's what 1 means. And we have 4/5 as well. So 5 and 4 makes 9. So 9/5. Now once we have them like this, so we've converted them to improper fractions, we can easily compare just like we did before. So we need to find common denominator between 5 and 2, and the easiest one to do would be 10, because 5 times 2 is 10. So to get 2 to 10 we multiply by 5, so I multiply by 5 the 7 as well, so that is 35. And let's convert this as well. So 5 times 2 gives me 10. So 9 times 2 gives me 18. And as you can see clearly, 35 out of 10 is bigger than 18 out of 10. So that suggests that 7 halves is greater than 1 and 4/5. So now let's have a look at if we had three fractions to compare with each other, what would we do? So we compared those two, but what if we had these three to compare using calculations, because we did a comparison before using common sense. So again, so the first thing to do is to convert all of them into improper fractions. This is already an improper fraction, so we don't need to do anything yet. And this needs to turn into an improper fraction. And as we looked at before, we converted that to 9/5, and we converted this to 7/2 as well. So it's a case of comparing 7/2, 9/5, and 5/4. Now, finding a common denominator. That means a multiple of all of these. So I used 10 between them two, multiplied 2 by 5 to get 10. But 10 won't actually work with 4 because you can't really get a whole number if you divide 10 by 4. So we're going to look for another multiple. So you could either continue listing the multiples of 5 and 2 and 4, and I'll show what that means. So if I go 2, because that's the denominator, then 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and so on, or you could stop at any point. And the multiples of 5, so 5, 10, 15, 20, 25, 30, bringing it to the same point. And multiples of 4, so 4, 8, 12, 16, 20. I don't need to go any further because I can see that 20 is appearing in all three of them. And that is what I'm after. It's a number that we can multiply all of these by and give an answer of a whole number. In other words, finding a multiple, a common multiple of all of them three. So 20 is the multiple we're going to be using. So we'll have 20, 20, 20. So let's convert this to a fraction with a denominator of 20. So to get 2 to 20, we'll multiply by 10. So we need to multiply 7 by 10 as well to make 70. To get 5 to 20, we'll multiply by 4. So we'll do the same. So 9 times 4 is 36. And to get 4 to 20, we'll multiply by 5. So we'll do the same. 5 times 5 is 25. Now, as you can see, the biggest one is this one, 70 out of 20. The next one is 36 out of 20. And the smallest one is 25 out of 20. So that is very easy to order them. So we've been able to order and compare them. What about adding and subtracting? Adding and subtracting is very similar to what we have just done when we ordered and compared. So if I want to subtract 5/4 from 1 and 4/5, so 1 and 4/5, take away 5/4, I would just convert them like I did into improper fractions. So that was 9/5, and that was 5/4, and then bring them to have the same denominator. So 9/5 was 36 out of 20, and 5/4 was 25 out of 20. So that is easy to take away now, because all you need to do is 36 take away 25, and that gives us 11 out of 20. So exactly the same, all you have to do now, rather than compare them, put a minus symbol in between them, between the two that you are subtracting, finding the difference of. And the same thing would be if I wanted to take away 1 4/5 from the 3.5, I would just do this. So 70 out of 20, take away 36 out of 20. How would we add? Again, 36 out of 20, add 25 out of 20. So that is 61 out of 20. That was the most important bit, or the hardest bit to do, because with these two, it must have been even easier, because we converted them to make them with a denominator of 30, because 5 times 6 was 30. So what we had then was 5 times 6, 30, 2 times 6, 12, and we have with 30, so we're multiplying by 5, so that's 25. So adding them together, 12 and 25, 37 out of 30. If you want to subtract one from the other, if you want to subtract 2/5 from the 5, 6, then we'd have 25 out of 30, take away 12 out of 30. So that gives us 13 out of 30. 13 out of 30. I'll rewrite it there. Or if you want to subtract 5/6 from the 2/5, then 2/5 was the same as 12 out of 30, take away 25 out of 30. So if you do 12 take away 25, that gives us minus 13. So it's the same as doing 25 take away 12, 13 minus, so the negative. So minus 13 out of 30. So I hope I've shown you here how to order, add, subtract and compare proper and improper fractions and mixed numbers. Practice this with fractions that you might be given, make them up, use dominoes because they look like fractions, add them up, subtract, order, compare them, because you need this skill in everyday life when it comes to sales, when it comes to adding and subtracting different amounts